So I just wanted to say thank you to Looker for having us here today. We're excited to be a premier professional services partner for Looker and GCP. I'm Sam Barron, COO of 4 Mile Analytics, and I'm joined today by David Stocker, 4 Mile Director of Software Engineering. Just a quick word about us. 4 Mile is a full-service consultancy that provides strategy and implementation across all layers of the modern data stack. We do data engineering, solutions architecture, analytics, software engineering through to UX design, product and project management. Our principal differentiator is the proven ability to design and deliver custom data applications and provide strategic consulting to enterprise customers seeking to accelerate the time to value of their data initiatives. So today we're going to talk about embedded analytics products, how we think about what's possible to do with data, and the process we use for designing and delivering impactful data applications, as well as how we identify new monetization opportunities for your data. So let's dig into data productization, and this really builds on what Colin addressed in this morning's keynote. So what is possible with data today? And the short answer, based on what we see in the market, is that it's possible to do a lot more than folks might think. Many organizations are so focused on dashboards, they're not aware of the incredible opportunities to move beyond KPIs and into workflows, AI, and automation, which really are the promise of embedded analytics made possible by technologies like the Looker API and the GCP stack that flatten the cost curve for advanced solutions, enabling organizations to more rapidly climb the ladder of analytic maturity. So the first step of the ladder on the left that we're all familiar with is descriptive analytics that deliver sense-making and insights through beautiful dashboards, providing a single pane of glass for business KPIs. But it starts to get much more interesting as we step into integrated analytics, when we add workflow context, breaking those visualizations out of the dashboard and driving them down into the workflows. And this is where we get into true data products, tailored applications that meet the user where they are to deliver the right insights to the right people at the right time. Next, we layer on predictive analytics with technologies like machine learning that trigger alerts, breaking us out of our workflows to deal with detected issues. This, however, is a bit like the undirected nature of descriptive analytics, where it's left to the user to figure out what actually to do. So the real magic happens when we add prescriptive analytics, which takes those triggers and directs the user to specific actions, data-driven decision support at the level of individual workflows. And finally, we reach workflow automation, where we can take the user out of the workflow entirely in some cases to maximize speed and efficiency. Note that as we move up and to the right, data, events, and actions get more and more real time. What enables all of this to work is data storytelling, really weaving a product narrative that combines visualization, alerting, and directed actions to not only meet the user where they are, but to get them where they need to be. And data storytelling is often connected to better data presentation, but we're now extending this into workflow context and actions. Product-level data storytelling requires asking the right questions to understand user workflows and needs. This is really the domain of user experience or UX design. Following the same ladder of analytics maturity, UX asks, what do users need to understand intuitively? How can we add workflow context around the insights? How can we drive workflows by predicting future states? What are the actions the user should take, and what's needed to manage automation? So to make this tangible, let's walk through a demo designed and built by 4 Mile that shows a trucking fleet management application offered by a hypothetical IoT parts supplier. In this case, the users are fleet managers the context is workflows around fleet management. The foresight and direction are around detecting and resolving issues like vehicle failures and changes to parts inventory forecasts. And the automation is woven throughout. So we're used to seeing dashboards, but now let's look at what's possible. Okay, so to begin with, you can see that we have a custom visualization at top with data layers overlaying a map of the United States. We have different layers that represent revenue per trucking route in this case, trips in the last week. I don't know how you're seeing it through the share, but this is a smooth, continuous animation showing relative number of trips. And we have finally fleet locations. So this is actually the locations of all the different vehicles in the fleet. We can select to view summary data of a particular vehicle, and we can drill right down into the vehicle information. So see information on this particular truck, its maintenance log. Here's an example of an embedded insight in the driver stats, and we can see driver information and origin destination. Down below the viz, we have Looker-powered cross-filtering. So we can not only get information about from the visualizations directly, but we can actually filter by clicking directly on them. So let's look at light-duty trucks that originated in Denver, and we can see that these are the routes and the trips. All right. We can also break particular tiles out of the dashboard with custom visualizations. So this is taking what might be standard information off of a reporting dashboard and adding context and analysis to it. In this case, we have fleet overview with a spark line, and we have a custom visualization of fuel consumption by truck brand. So now let's get into the predictive and prescriptive aspects that I was talking about. If we go up here, we see that we have a couple of alerts that are waiting for us. So we received a notification that there is a predicted part failure on a particular vehicle. If we click that, we go right into the workflow, and we see that the flux capacitor on this particular truck, TensorFlow has predicted this part will fail based on the vibration signature being out of range, and the part should be replaced within the next 3 operating hours. So that's the predictive part of it. We flagged that there is an issue with this particular truck and this particular part. The prescriptive, directed part of it is the recommended solution, which in this case is a recommendation by the system to swap trailers in order to have on-time delivery of an expedited load. It provides the recommended depot and provides the step to take the action. So we're going to initiate the tractor swap. We go ahead and begin that. We're presented with an option to notify the driver via text with a Google Maps link to the depot location, and we send. And with that, the parts issue is resolved. We also have another notification up here, which tells us that based on the failure that we just had, we need to adjust the survival curve for this part, meaning that the life expectancy for this part has changed. It's become a bit shorter. And that life expectancy or survival curve is used in our inventory forecasting over the next number of quarters. So the predicted inventory need for this part has also changed. This has had a budget impact. That budget impact is displayed, and we're presented with the option to approve the updated forecast, which we go ahead and do. So 2 examples of prediction and prescription where we've been alerted and directed to take a specific action. This demo also has other functionality, more traditional reporting, and the ability to go ahead and explore the data. But this is really what I wanted to show today to exemplify what we're talking about here. So now let's understand how we go about designing this sort of data application. First, it's essential to begin with a clear product vision. A product is not just a collection of features. We need to start by asking, what is the potential impact of an ideal product on the user and the overall organization? We then take incremental steps toward that vision using an iterative process of discovery, design, and implementation. And the goal is to achieve the product vision with an application that fits the use case or the market, meaning that it provides high value by exactly addressing the user's needs. We start with discovery, seeking to understand as much as we can about the user and especially their pain points. And we also seek to understand the use case or market context, which might be for internal teams, or it could be for customers currently using competitive products. In 4 Mile's case, we usually begin with a discovery sprint that features intensive workshopping with key stakeholders around the organization's needs and potential opportunities. And then based on the results, we design features and workflows that solve identified user problems. To do that, we bring a multidisciplinary cross-functional team, all of whom have early input into the design. We then implement just enough of the solution that we can test the value of the design, meaning we can see if the design really solves the user's problems and whether the design is intuitive to use. So we put that implementation in front of users, going back to the discovery step, to learn more about the user and how well the product solution fits their needs. And in each cycle of this process, what we implement becomes more and more robust. So we might start by testing a paper printout of the product design to see if users understand it, and then move in the next cycle to a clickable prototype, and then a minimum viable product, the smallest set of software features that address the core user need, and finally continue to iterate our way to full-blown product maturity. Through this process, how we achieve the high-level product vision might change radically over the course of the engagement. But by iterating, we are destined to converge on the right solution. And note that this process is really familiar to software product teams, but it's a new approach to delivering value through analytics. What's great about this product development process is that it can also be used to find new ways to sell or monetize your data. The goal is to find a valuable home for your unused data exhaust, or ways to repackage already applied data that offer new value to a different audience. And that was really the scenario in the demo we just saw, where the hypothetical part supplier found a new use case for the IoT data they were already collecting for product improvement. So we begin this with data availability analysis. What data is available and what could be collected or made available. We then focus the discover, design, implement process on uncovering new use cases. We test those use cases with users, perhaps starting with internal teams and then moving to beta customers. And once we've confirmed that a use case and its product solution are solid, has legs, we develop a go-to-market plan and roll out the new product. All right, so this wraps up the overview of productizing data. I'm now going to hand off to David to talk about how the demo you just saw can be implemented on GCP.
Yeah, thanks, Sam. And again, I'm as well delighted to be here with you and everybody. I'm going to talk about a reference technical architecture or a conceptual technical architecture for bringing a solution like the one you just saw to life. And before I do that, I hope you will allow me a brief editorialization. The components, the tools that are available, like Looker and other data products in the GCP suite, are so powerful, easily integrated, and expressive without really a heavy data plumbing burden, which means that we technologists can focus on the things that matter most, that end user experience, finding that product market fit, and iterating quickly. And I think that you'll see as we walk through our reference implementation, how that was possible in the use case that Sam described earlier. So our starting point is really this need to productize IoT data. We have a fleet of trucks that's emitting a stream of telemetry from devices at the edge that ultimately we want our users, who are control room operators, to be able to interact with, interactively query, and act upon within a single pane of glass. I'm going to talk about some of the other architectural or kind of foundational architectural drivers that has informed some of the design decisions that I'm going to share with you today. The first is the need to support multiple data experiences. Under this scenario, our hypothesis is, yeah, we've got a group of control room operators, but there's other actors out there in our enterprise who might derive value from that data as well. There's end customers, maybe there's maintenance managers. So there's a need to support multiple data experiences. The first technology that we can bring into our stack to facilitate and make it easy to support multiple data experiences, in this case, is Firebase, which is a GCP product. It's a platform as a service that brings a whole list of core application tools that virtually every web application requires. Having these building blocks that snap together almost as easily as Lego blocks will make it easier for us to spin up new portals and even say, we're going to try something, we're going to test it. If it ends up not working out or failing, we can scrap it without having a huge amount of sunk costs. So that platform gives us web hosting, cloud APIs, authentication, real-time databases, and a whole long list. Looker, as we heard from the previous talk, gives us a core SDK giving first-class access to the Looker API, as well as an embed SDK, which makes it dead simple to bring in Looker objects like looks, explorers, and dashboards in a snap, just a few lines of code. Having these tools in our toolkit means that the application developers can really focus on that end user's needs, bringing their own UI framework, the appropriate kind of high-end tailored visualizations, and that workflow logic that is specific to each application. So the next architectural driver that we're going to concern ourselves with is the need for a single source of truth. If in this scenario we have various actors working in different experiences or different portals, they're going to be asking different kinds of questions to the data, but the answers the system produced have to be internally consistent. So BigQuery is obviously going to give us a huge lift in that area, having a consolidated data warehouse that's driving a range of different related use cases, gives us that assurance that our fact tables are consistent, and not only over time, but in terms of the definitions themselves. However, BigQuery itself is still pretty raw. We want our developers to move fast, and with just BigQuery, they have to write very expensive and brittle SQL queries that can be hard to test and might drift from each other over time. That's where Looker really shines. So we introduced Looker into our stack to make it to give us assurance that the kinds of questions that users are asking will produce consistent answers. It also makes it dead simple for application developers to ask those questions via Looker's API. A query or an API request might be as simple as something like what we see in the upper left-hand corner, replacing 50 lines of SQL with a few lines saying, give me the average revenue per trip and pivot by origin. So the next architectural driver that I want to highlight is the need for data quality. Garbage in, garbage out. We want good quality data coming in to our platform so that our users get good quality answers. IoT is it's a pretty strange beast when it comes to data quality because we can't predict that data is going to land in the right order. IoT devices might have different versions, be producing data using different versions of a schema. We might have duplicate data. And so that's where GCP's Cloud Data Flow gives us a big lift. It deduplicates, it normalizes, and otherwise pre-processes our data so that by the time it's landed in BigQuery, it's consistent and of a high reliable quality. The last piece of this particular workflow I want to highlight is how do we ensure that data coming in the head end of our solution offers reliability and trust. The IoT data, we might have very high volumes during the day and very low volumes during the night. So what IoT Core gives us is a high availability gateway with built-in authentication so that we know that the devices connecting to our system are in the family, so to speak. Finally, the last thing I want to highlight is the need for prescriptive or real-time predictions. Everything we looked at so far is to drive retrospective use cases because we need to alert our customers that something has gone wrong. So at a glance, what we're looking at here is the application of a TensorFlow model, which can be run on our cloud data flow pipeline. That TensorFlow model has been trained to detect abnormal conditions. And when those events occur, publish that onto a cloud pub sub. Because all of these tools are built out of the box to integrate, Firebase itself, with just a few lines of code, can subscribe to that pub sub topic, take that event, and write it to a cloud Firestore document data store. What's so cool about this is the document data store, Firestore, can push changes that are written to this data store in real time to connect to web clients. So it's really just a few lines of code. We're able to tell all of our connected users that something has gone wrong and they need to take action. So that really is at a glance what the reference architecture looks like. And just to wrap things up, I say, because these components are so powerful, easily integrated and expressive without that heavy data plumbing burden, you can deliver a significant amount of value to your customers. You can find new boundaries for what's possible with the data, and you can climb the ladder of analytics maturity faster than ever before. And with that, I want to say thank you so much for joining our talk. And feel free to reach out with us if you'd like to discuss any topics or ask questions.